Hi, welcome to Chapter 2, Lesson 6 of our Basic Calculus class, or this is called Implicit Differentiation. So our goal for today is, first, to compute the derivative of an equation using implicit differentiation and to solve problems using implicit differentiation. First, what is implicit differentiation? So implicit differentiation is the process of differentiating a function implicitly. So in the previous topics, we performed the differentiation explicitly, by which the variable f of x or y is explicitly described by x, and it is done by the types or methods that we previously discussed. So we've discussed some of the differentiation rules, okay, in our previous lessons. So you can watch the videos in our basic calculus playlist. In finding the derivative of implicit form of a function, x is normally differentiated while y is differentiated. However, it is multiplied by dy over dx. So consider the function or consider the equation xy equals 1. So for us to solve the equation explicitly, we need to transform it to y in terms of x. So we have the following. So we have xy equals 1. So we divide both sides by x so that x will be cancelled out. Okay, so that will be y is equal to x. After this, we then compute the derivative, but for the implicit differentiation, we just compute it directly without expressing y in terms of x. So here are a few examples to make it clearer. So here we have to compute the derivative using implicit differentiation. Example number 1, we have the equation x plus y squared equals 2. So to solve, we get the derivative of each. So x has a derivative of 1, so we simply put 1, plus derivative of y squared is 2y raised to 2 minus 1. Then, since we are differentiating the variable y, so we put or we multiply it by dy over dx equals derivative of 2 is 0. Next, we simplify. That is 1 plus 2y dy over dx equals 0. Then, we subtract 1 to both sides of the equation so that we will eliminate 1 here. And what will be left here on the left side will be 2y dy over dx equals 1 will become negative 1. Then, take note what we need is simply dy over dx. So to eliminate 2y, we divide both sides of our equation by 2y. So what will be left on the left side is dy over dx equals negative 1 over 2y. Or that is also the same as negative 1 over 2y. So dy over dx, or the derivative of the given equation, is negative 1 over 2y. Example number 2, we have x squared plus y squared equals 25. Now, to directly get the derivative using implicit differentiation, we get the derivative of x squared. So, every time that we get the derivative of x, so we simply get the derivative using differentiation rule. So that's 2x or 2x raised to 2 minus 1, or simply 2x. Okay. Then, plus derivative of y squared. So that's 2y raised to 2 minus 1. Then, since we are getting the derivative of a variable that is y, so we put dy over dx equals derivative of 25 is 0. Then we simplify, that's 2x plus 2y dy over dx, that is equal to 0. Next, Okay, we only need dy over dx on this side. So 2x, put that on the right side. That's negative 2x. So 2y dy over dx is equal to negative 2x. Then divide both sides by 2y so that what will be left is dy over dx on the left side. So what you will have, okay, again, so divide by 2. So what will be left is y dy over dx equals negative x. Then to eliminate y, we divide both sides by y. Or you could just divide by 2y. Okay, you will get the same answer either way. So dy over dx is equal to negative x over y, or that's negative x all over y. Okay, third example, we have xy equals 1. Take note, xy is x times y. So we can get the derivative of xy using the product rule of differentiation. So product rule is, first copy x times the derivative of y. Derivative of y is 1 dy over dx. Plus, we copy y times derivative of x, that's 1. Okay, so we don't need to put dy over dx here since we only took the derivative of x. Equals, derivative of 1 is 0. So we simplify x times 1 dy over dx, that is x dy over dx, plus y times 1, that's y, equals 0. So we only have to have dy over dx on the left side of our equation. So we transfer y to the right side, that will become negative y. So we have x dy over dx is equal to negative y. Then divide both sides by x. So that's dy over dx equals negative x. Or dy over dx is negative y over x. Okay. There are various applications of implicit differentiation. But first, we have to take note that dy over dx simply means that it is the rate of change of y. So, if y is increasing, then dy over dx is positive. If it is decreasing, then dy over dx is negative. And if it is constant, or if it does not change, then dy over dx is 0. Take note, the same will be true with other variables. Now, here are some applications of implicit differentiation. Example 1. Two ships are sailing from a port. Ship A is sailing due north, while ship B is sailing due east. At a certain time, the distance of ship A from the port is 40 nautical miles, while the distance of ship B from the port is 30 nautical miles. What is the rate of ship B as she sails if the speed of the ship A is 10 knots and the rate of the distance from ship A to ship B as it increases is 25 knots? So hint, 1 knot is equal to 1 nautical mile per hour. So take a look at the illustration below to make this problem clearer. Now we have here ship A, because it is sailing due north, okay, 40 nautical miles away from the port. So if this is the port, this is north and 40 miles away. Next, ship B is sailing east of the port, okay, 30 nautical miles away. Now, to solve this problem, let us first understand the basic facts here. Take note, x here is represented by 30 nautical miles because that is the distance, or the horizontal distance here, which is represented by the distance of ship B from the port. Okay, we don't know dx over dt yet. Y is 40 nautical miles because that is the vertical distance, okay, vertical distance of ship A from the port. And dy over dt, or the rate of ship B, is given here as 10 knots, okay, or rather ship A, that's 10 knots, and z is the distance between ship A and ship B, which we do not know yet, and the rate between ship A and ship B is given as 25 knots. So that's why we have dz over dt as 25. So what we need to do first is we have to find the distance between ship A and ship B. And we can do that by using the Pythagorean Theorem. So that's x squared plus y squared, or the square of the legs, is equal to the square of the hypotenuse. So hypotenuse here is z squared. So that is x is 30, so that's 30 squared, plus y is 40, so that's 40 squared, equals z squared. Okay, so that's 900. 30 squared is 900, and 40 squared is 1,600. Then z squared is 2,500. So to find z, we have to get the square root of 2,500. That is 50. That means the distance between ship A and ship B at a certain time here is 50 nautical miles. However, what we need to do here is to find the rate of ship B. Okay, so that is dx over dt. Okay, so we have to find dx over dt. So we have to use implicit differentiation. So get the derivative of x squared plus y squared equals z squared. So that's 2x dx over dt plus 2y dy over dt equals 2z dz over dt. Take note, we have to put all of this because x, y, and z were all taken as a function of time, or that's why we have dt. Okay, so we can divide all of this by 2. So you get x dx over dt plus y dy over dt equals z dz over dt. So substitute this from the given information that we got from our problem. So x is 30. We don't know dx over dt yet. Y is 40. Okay. dy over dt is 10. Then equals z is 50. And dz over dt is 25. So we have 30 dx over dt plus 40 times 10, that's 400, equals 50 times 25, that's 1,250. Okay, so dx over dt is now equal to 1,250. Then we transfer 400 to the other side, so that's minus 400. So that is equal to 850. Then divide both sides by 30. So that's 850 divided by 30, or that's 85 over 3, or that's 28.33. Okay, so therefore, the rate of the ship B as she sails to the east is 85 over 33, or 28.33 knots. Example number 2, two ships, Ship A and Ship B, are 36 nautical miles apart. Ship A starts sailing due north at a rate of 20.2 knots. At what rate is the distance between the two ships changing when Ship A is 15 nautical miles afar from her original position? So, to make this problem clearer and easier to solve, let us look at this illustration. Now take note, this is the original position of Ship A, and this is 36 nautical miles apart from Ship B based on our given problem. However, okay, so Ship A starts sailing due north. So Ship A goes north, at 20.2 knots and is now 15 nautical miles apart from her original position. Okay, so take note, we let x be the distance from the original position of ship A to ship B. Y is the distance from the original position of ship A to the present position of ship A. And Z is the distance from ship A to ship B. So we have here the following from the problem. So X, or this horizontal distance, is 36 nautical miles. So that's why we have X equals 36. Dx over dt, okay, we don't know that information yet. Y is equal to 15 nautical miles, or this is the vertical distance here. Dy over dt, or the rate of ship A, okay, so that's 20.2 knots. Then, we don't know Z yet, and we don't know dz over dt yet. Okay, so first, we need to determine Z. And to do that, we can use the Pythagorean Theorem. So we have x squared plus y squared equals z squared. So from our given here, okay, x is 36, so that's 36 squared. Y is 15, so we have 15 squared. And we have z squared. So 36 squared is 1,296. 15 squared is 225. So 1296 plus 225, that's 1521 equals z squared. To get z, we need to get the square root of 1521, and that is 39. So we now know that the distance between ship A and ship B is now 39 nautical miles. Okay, so next, to solve for dz over dt, we will use this Pythagorean theorem and use implicit differentiation. Again, that's x squared plus y squared equals z squared. So we have, using implicit differentiation, that's 2x dx over dt plus 2y dy over dt equals 2z dz over dt. So we can divide all of this terms by 2. So we only get a simplified form, that is x dx over dt plus y dy over dt equals z dz over dt. Now we will substitute our given values here. So take note, we have x is 36. Okay, dx over dt, or that is for ship B, that's 0 or constant because it did not change position. Only ship A changed position. Plus y is 15. dy over dt is 20.2 equals z is 39 times dz over dt. That is what we don't know yet. So 36 times 0, that's 0. 15 times 20.2, that's 303, equals 39 dz over dt. So this is 303, and we divide both sides of our equation by 39. So that's 303 divided by 39 equals dz over dt, or that's 7.77 knots. Therefore, the rate of the distance between the two ships changing when ship A is 50 nautical miles afar from her original position is 7.77 knots. All clear? So you can now solve the other examples that you will encounter on your own. So that's it for today. I'll see you next time. Bye!